In this video, we will investigate the exponent rules with negative exponents and 0 as an exponent. So let's talk about powers and exponents here. We're going to start out with a base of 2, and we're going to figure out some values. So we know 2 to the first power should be 2. 2 squared should be 4. 2 cubed is 2 times 2 times 2, which is 8. 2 to the fourth is 2 times 2 times 2 times 2, which is 16. And 2 to the fifth should be 32. Well, all we're doing each time is multiplying by 2 again. We're multiplying by another 2. So 2 times another 2 is 4. 4 times another 2 is 8. 8 times another 2 is 16. 16 times another 2 is 32. So what if I wanted to go the other way? Well, 32 divided by 2 is 16. 16 divided by 2 is 8. 8 divided by 2 is 4. 4 divided by 2 is 2. So now let's use that same logic to work backwards in this table. How would I get this next block here? Well, I know to work backwards, I'm going to have to divide by 2. So I take this value here, 2, and divide by 2. And 2 divided by 2 is just 1. So 2 to the 0 power is 1. But what if I take this 1 and I want to go backwards one step? I'm going to have to take that 1 and divide by 2, which means that 2 to the negative 1 power is going to be 1 over 2, because 1 divided by 2 is 1/2. If I took 1/2 and divided by 2 again, I would get 1/4. So 2 to the negative 2 is equivalent to 1/4. Divide by 2 again, and divide by 2 again. Well, let's look a little deeper here. Do we notice a connection between the 16, the 8, the 4, and the 2 with maybe the other side of the table? Notice that the 16 over here on this side was 2 to the positive 4. But 2 to the negative 4 was 1 over 16. Well, 2 cubed was 8. So we have 2 to the negative 3, which is 1 over 8. Is there a way we could rewrite these to look at those exponents? Maybe instead of writing 1 over 2, we could say that 2 is really 2 to the first power. And so I could replace that with 2 to the first power. And maybe I could say instead of 1 over 4, 4 was really 2 squared. So instead of writing a 4, maybe we could write 1 over 2 squared. Instead of writing 1/8, we could write 1 over 2 cubed. And instead of writing 1 over 16, we could write 1 over 2 to the 4th. Now, of course, we would want to simplify it, but this is really just to recognize the pattern. Notice here those negative exponents, when we write 1 over, that exponent now becomes positive. It was 1 over 2, or 1 over 4. So when we flip that, notice the negative exponent becomes positive. Let's take a look with a base of 3. We'll start out with 3 to the first power is just 3. If we multiply times 3 again, which is 3 squared, we get 9. Times 3 again, we get 27. Times 3 again, we get 81. Times 3 again, we get 243. Working backwards in the table, we can have 3 divided by 3, which is 1. Notice how those are equivalent. So anything to the 0 power looks like it's equal to 1. Now what would 3 to the negative 1 power be? Well, that's going to be taking this 1 and dividing by 3, because that's our pattern in the table. 81 divided by 3 is 27. 27 divided by 3 is 9. Divide by 3 again. Divide by 3 again. Divide by 3 again, and we get 1/3. 1/3 divided by 3 is 1/9. 1/9 divided by 3 is 1 over 27. 1/27 divided by 3 is 1/81. So notice again we have that pattern. What I want you guys to work on your own with is rewriting these using that exponent pattern that we did here. And then I want you to complete the table for a base 10 and a base of x. Hopefully you guys are seeing that pattern in the previous page where we looked at negative exponents giving us the reciprocal. So if we have something raised to the negative squared power, what that would look like is 1 over that something squared. And so it really is just the flip of whatever that term is with that negative exponent. But in expressions, we don't want to leave the negative exponents in our answers. So we have to really figure out how to manipulate those negative exponents and where we should write them. So we're going to take a look at this example here, x cubed y squared z over x to the 5th yz squared. First, we're going to take a look at the expanded form when we write it out. So this is what this would look like. We have x cubed y squared z, all written out in expanded form, over x to the 5th times y times z squared. So all of those are expanded out. If we were to simplify this, we would get rid of a pair of z's by reducing them away to 1, getting rid of a pair of y's, and 3 pairs of x's would reduce away to 1. So what we're left with is a y on top, x squared on bottom, and a z here. So that looks like y over x times z. Now let's take a look at what that would look like with our quotient rule. So our quotient rule means we subtract the exponents when we're dividing. So I have x cubed divided by x to the 5th. So 3 minus 5 gives us a negative 2. So that when we look at this, we have x to the negative 2. 2 minus 1 gives us a positive 1 exponent on the y. And 1 minus 2 gives us a negative 1 exponent on z. So how are these two related? Well, what we did in the previous page is we looked at the negative exponent really being the reciprocal. So where would we place that x squared? We'd place it on the bottom. Z to the negative 1 would be placed on the bottom. So it would look like y over x squared z. So looking at this example, let's write a rule. What do we do with those negative exponents? We're going to flip the variable with the negative exponent to the opposite side of the fraction bar. Another important note to make here is that we make that exponent positive when we move it down. That's because we have those x's here, and x times x is x squared. So in the bottom, now that 2 is positive. All right, let's take a look at some examples. X to the negative 3, y to the negative 2. We're not going to leave our expression written with negative exponents. So this is like saying this is over 1. So we can write it with a fraction bar, and we can move that negative 3 to the bottom and that negative 2 to the bottom. So that's going to look like 1 over x cubed y squared. We can also use our rules the exact same way with negative exponents. So we have our quotient rule here. 4 minus 5 is x to the negative 1. Negative 2 minus 2 is a negative 4. And now we need to get rid of those negative exponents. So that becomes 1 over x, y to the 4th. We have a to the negative 5, b to the negative 2. Both of those negative exponents would get flipped to the bottom. And we have 1 over a to the 5th b squared. I want you guys to take a look at these last 3 on your own, and then try to fill out the last part of your foldable.